The focus of this lesson is on graphing a polynomial function, and in particular, this function is in factored form. So in order to get the overall sketch, we're going to have to look at a few different pieces. So the first piece that we're looking at is the leading term. Now, if we were in expanded form, the leading term would be obvious. It would just be stated as and just a given. But because you're in factored form, it may not be as obvious. So what you want to do if you're in factored form is look at each of the individual factors, including their power. Okay? And then you want to take the leading term of that factor. So this is only a one-term factor, so we've got negative 2x squared for the first factor. Now for the second factor, the leading term is x. And then the power on that factor is 1, so x to the first. And what I'm going to do is I'm going to put a time symbol here because that's how we're going to put these together. And then we'll put another time symbol for this third piece. So we've got x as the leading term, but then the power is 4, so it's x to the fourth. So do you see that? We had negative 2x squared, and then wasn't raised to anything else. And then we have x, and that was raised to the first as far as the leading term goes. And then we have leading term x, and then that's raised to the fourth. So then what you do is you multiply all those pieces together. So negative 2 times 1 is negative 2. And then x squared times x to the fourth is x to the seventh. So that's our leading term. And so that's going to determine our end behavior of our graph. Because the power is odd, we know that the end behavior is opposite. So one side will go to the right, one side will go to the left. But we have a leading coefficient of a negative 2. So that tells us which way the behavior goes. So we're actually going to go, because it's negative, we are going to go down on the right and up on the left. Okay. So I'm going to kind of just doodle that in. Down on the right, up on the left. So we have opposite end behavior because our power is odd, and because that leading coefficient's negative, we're down on the right as opposed to up on the right. So and we knew it was opposite, so therefore we're going to go up on the left. So that's our end behavior. So then we work on the Y-intercept. So in other words, where we cross the y-axis. Again, if you were in expanded form, it would be obvious, it'd be the constant. But we're not in expanded form, we're in factored form. So if you're in factored form, think about what a y-intercept is. It's when your x value is 0. That's how you end up on the y-axis. You have no horizontal movement. So you want to let x be 0, and then just evaluate your function at that x, so at 0. So what is f of 0? So wherever there's an x, put in 0. And so if you do that, you can see it actually doesn't matter what everything computes to. You have this 0 squared, which is 0 piece, and so that means if you multiply that all together, it's going to be 0. So you can see that when x is 0, y is 0. And so you have the ordered pair 0, 0 is your y-intercept. So 0, 0. Okay? So then we want to move on, and we want to focus on the zeros of our function. Now, this is where it's nice that we're in factored form, because that means that our zeros are more obvious. So your zeros are where your function is 0. So in other words, where each factor is 0. So when is negative 2x squared 0? Well, when x is 0. That's how that would happen. When is x plus 1 0? Well, when x is negative 1. In other words, solve for x. Where is x minus 3 to the fourth 0? Well, where is x minus 3, 0? Well, when x is 3. And so you can kind of get your zeros. In other words, these are the values that make the function 0 when you plug them back in. And so you can kind of see it's more obvious. Okay, oh, I need a -1. Oh, I need a 3. I need a 0. So those are your zeros. So then what I would do is I would plot those on your graph, because you know that your graph is going to hit those. And so your zeros are on the x-axis. So x is 0 is already plotted because of our y-intercept. X is -1 and x is 3. And then we have to determine our behavior at each of those zeros. So what is the behavior at the zeros? Well, it depends on the multiplicity or the power that was present on your factor. So in our -2x squared factor, x is squared, so we have a multiplicity of 2. In our x plus 1 factor, it's raised to the power of 1, so our multiplicity is 1. And then in our x minus 3 to the fourth factor, our multiplicity is 4, because that power is 4. Now, if you have even multiplicity, then you touch or bounce is the word. I kind of call it bounce, but I think the textbook calls it touch, so I'll just use what the textbook says. So touch is when your multiplicity is even. So we're going to touch at x is 0, and we're going to touch at x is 3. But when your multiplicity is odd, you're going to actually cross that x-axis. So keep that in mind. So now we're going to kind of move from left to right in our sketch. We basically have everything. And again, this is just kind of rough, kind of going through it. I'm going to hit at -1, and that -1 it says I'm supposed to cross. So you do. And you don't necessarily know how far it's going down, but you need to get back up to your other 0, so you need to turn around. And when you get to that other 0, that's at 0, it says that you're supposed to touch. So you're not supposed to cross all the way through the axis. You have to kind of bounce like a ball, bouncy ball, and bounce back down, or touch. And then eventually you have to get back up to your 0 again. And in this case, this is at x is 3. And at the x is 3, it says we touch again. So we don't cross through that x-axis. We kind of bounce. We just touch it and then come back down. And then when we do that, that allows us to get back down to our down behavior. And so that's a rough sketch of your polynomial function. And again, you don't know how low those valleys go, but that's the general idea to sketch a polynomial function. So you need the leading term, you need your y-intercept, and you need your zeros and the behavior at those zeros to graph appropriately.